In this webcast, we're going to focus on finding the max height, flight time, and range of an object in projectile motion. The max height is the height the object actually reaches at its peak. The range is the x distance that the object actually covers if you fly across a horizontal surface when it comes back to the same height. And the flight time is how long it takes before it hits that point right there. So in order to do this, key thing to note is that the max height, the velocity is 0. So the velocity is found, we actually want not the velocity, we want the y component of the velocity to be 0. So we're going to let negative gt plus vy naught to equal 0. If you solve this for t, it's the only variable, g and vy naught would be something you know. Then we can solve for t, and t is, that to both sides, giving us vy naught, and then divide by g. And this is the time to max height. Since that's the time to the max height, and the max height is a y value, I'll come to the y values, which are located in the y component of the position, and we'll replace the t in here. So I've got a negative g. I'm going to replace the t with the vy naught over g. And then I'll replace the vy naught, and now I need to replace the t with the vy naught over g. This should be our max height. Whenever you're trying to find a general formula, normally you simplify as much as possible, otherwise that formula looks ghastly ugly. So here, notice there's one g in the numerator, but there's two g's in the denominator, so that all means I'll end up with a g in the denominator. There's also a 2 that remains in the denominator. And then there's a vy naught squared in the numerator. On this term, I end up with a vy naught squared over g. So essentially, what I've got is each term has a vy naught squared over g in it. But then the first one, there's a minus a half, and the second one, there's a 1. So this ends up equaling 1/2 vy naught squared over g. And that is our max height. To get the flight time, it's actually fairly simple. If half of the way is to the max height, then the other half of the time is going to be spent reaching the range. So that means the flight time is twice the time to the max height. So twice vy naught over g. That takes care of the flight time, so if I want the range is simply put the flight time in for the x-coordinate of the position. So vx naught times the flight time, which is 2 vx naught vy naught over g. If you now convert this back into v naughts and alphas, then this is 2 v naught cosine alpha, v naught sine alpha over g, which equals 2 v naught squared. I'm going to actually put the 2 on the other side. 2 cosine alpha sine alpha over g. And back in trigonometry, most of us probably forgotten, this actually is the same thing as as sine 2 alpha, which means you can rewrite it as v naught squared over g times the sine of alpha. However, this formula right here is normally sufficient for knowing the range, but you may occasionally see that formula. That takes care of this webcast.